Hey guys, welcome back. It's Adam the Science Tutor here, and today we're going to be talking about Sn1 versus E1 versus Sn2 and versus E2. So we're going to go over some big concepts today. We're going to go over the mechanisms, but specifically we're going to look at Sn2 and Sn1, and then in future videos we're going to look at E1 and E2. But I'm going to give an overall breakdown, and this is a table I make that is very important to learn. It's with methyl 1' substituent, which we will talk about, 2' and 3', and then it's separated into strong bases, weak bases, or no nucleophile. So the different categories, and we're going to be talking about it. We're going to go over some sample problems and where I'm going to point out where to go and what we can look at. Here I've listed some weak bases and some strong bases. Sorry, I should have added that, but these are weak bases and strong bases. And here's a new vocabulary word for us. It's protic, and a protic molecule can donate hydrogens. So some examples of that would be H2O, ETOH, and OH. So these are different molecules that can donate the hydrogen. So the oxygen can get rid of the hydrogen if it wants to. There's some weak bases, strong bases, and so yeah, we're going to go over this, and pretty much I would have you guys write this down. It's going to be in the worksheet in the bottom, and we're going to get going here in a bit, and we're going to see what we can do and how we can work out several problems. So I'm going to go ahead and erase this. Hopefully you guys wrote this down. This is just a little bit of extra information so that you guys can understand what's a weak and what is a strong base. So, but the rest of it I'm going to leave up throughout the video, and that way we can go over it and see a couple different things. So our first problem, and also another key point I wanted to say, is that Sn2, everything happens at once. Sn1, it's a bimolecular, it happens in 2 steps. So it's going to be 1 and 2, and it sounds a little odd, but it's just the way that I think that scientists discovered Sn1 first, the Sn1 mechanism first, before Sn2. But Sn1, there's 2 things that happen. And Sn2, there's only 1 thing that happens, so it's a little opposite. But first I'm going to go over Sn2 mechanism. So we have here, well, scratch that, alright, cut that. Alright, never mind. We're going to go over what's a methyl, what's a 1', what's a 2', what's a 3'. And then I'm gonna give you guys some problems. So this, just so you guys can learn. I don't know if you guys have covered it yet in class, but it is something that you need to know. Okay, and this. Okay, so we're gonna go with. Let's change this one out. Let's go. Okay, so let's look at here, and I'm gonna have you guys tell me which one goes where. So I kind of did it in order. My bad, poor planning on my part. But this is obviously this is a methyl right here. And a methyl obviously goes here, so it can only act as this Sn2, and no nucleophile. This is a 1' because you look at the substituents. So this is your first carbon here, and what is it connected to? It's only connected to 1 other carbon. Therefore, it's 1'. The carbon that has the substituent has only 1 carbon attached. So this is a 1'. This is a methyl. This one right here, we look at the carbon that's attached to the substituent. It's right here. What is it connected to? It's connected to the bromine. That's because of 2 carbons, so it's a 2'. This bromine is, look at the carbon that it's attached to, and it's 1, 2, 3'. So you have a 1' methyl, 1', 2', 3', and we're going to look at how to do these Hope you guys wrote this one too. I'm gonna make a little bit more space for me. All right, so right now we have 1, 2, 3, 4. So it's a 4. It's a butanol. My bad. It's a butanol, and we're gonna react it with a hydrogen bromo. So the mechanism with this is that and let's go ahead and look and figure out where we're at, what we're looking at. So it would be an Sn2 reaction. It's a 1', and it's a strong base. This is a strong base. It's stronger of a base than it is an acid because it has that H to donate. Actually, it's a weak base. My bad. So, but it would still be an Sn2 because it's a weak base. But yeah, we're gonna go over it and we're gonna see how it works. So you have your H, Br, and you have the OH. Two dots. Okay, so the electrons on the oxygen are gonna look at going right towards the hydrogen because it wants to make a water. Water always wants to leave, so if you see an OH group, it more than likely wants to leave. It wants to detach. So when a bond is formed, a bond is broken. So the hydrogen is going to break off from the bromine. Now you're going to have a bromine with all of its 8, and you're also going to have a hydrogen here with now another hydrogen. And Sn2, everything happens at once, so this happens simultaneously. As this electrons break off and form the water, this carbon is going to attack, these electrons are going to attack that carbon. The electrons go to the positive. So your final answer will be bromo, like that. I know it's written kind of ugly, but it's going this way. So the hydrogen bromo will break off. It'll attack the carbon that is letting go of the water molecule now, and it will be attached at this 4th carbon. Hope you guys can see that. Hope you guys can see that where we related to our table. I'm lacking a lot of room here, but that was that one. That's for the 1'. 2'. See, this thing has a negative here. Okay, so for this one, it's a 2'. So we're gonna look at 2'. So we could either do elimination 2, Sn2, Sn1, E1, E1. This is the Protic. My bad. That was up here. That was the Protic. Sn1's Protic. And we're gonna see which one this one is. So this is a weak base, and so we're gonna either do Sn2 or Sn1. This doesn't have any hydrogen, so it can't be Protic. So it's an Sn2 reaction. So Sn2. How do we know this? Because it's Protic. This one's a Protic, this one is the Aprotic. This does not have hydrogens to donate, therefore it's Aprotic, and it's a weak base. So, how are we going to start this? Let me show you the mechanisms. So, Sn2, everything happens at once. So this is going to break off, getting rid of the bromo. And these electrons right here are going to attack right there. So you're breaking a bond, and once you break a bond, you always have to form a bond. So our answer would look like this. Plus your bromo. So there's your bromo, and you're seeing attached right where it kicked off the bromo. That is your mechanism. Your electrons are attacking that carbon as soon as and it's going to break the bond and give its electrons to the bromo. So it's gaining and giving away its electrons. Finally, let's look at our 3' bromo, and it's going to be very similar to the 2'. So let's see. All right, here's a 3'. Sorry, let's see. So what was it? That's 2 here. Okay, so we obviously see there's an elimination 2, there's a substitution, and there's an elimination 1. So this is 3'. We know it's there. We know this is a weak base. It's a weak base. Therefore, it'll be Sn1. So we'll finally get to our Sn1, and we'll see how that works. Sn1 is 2 steps. So there is going to be an intermediate. So let's see. So our intermediate. So it's very simple. It's just you're going to break it up. So you're going to form a carbocation. And Sn1, a carbocation, is formed. So you're going to form a carbocation, which is this right here. So it has a plus charge, and then you're going to have a bromo, the negative charge. This is your intermediate, and then your intermediate still being attacked by this the Cn. It's going to come in here and form your product, which is C in here. Ooh, sorry about that. So as you can see, it's an Sn1, it's a weak base, and it attacks the carbocation. But a carbocation is formed from Sn1 because it's bimolecular. It happens in 2 steps. It doesn't happen all at once. It's broken up in 2 different steps. So these are some problems I worked out. Hopefully this helps. I'm going to go over a few more problems so we could understand it a little bit better. I know it's a little complex, but you'll get used to it. Methyl is a bit confusing, but it can only work in Sn2s. So for example, let's see. We'd have to kick off a hydrogen, really. But no, that's not much with methyl. You won't be asked too many questions with methyl, but really just pay attention to the 1', 2', 3'. And once again, how we see what is this carbon attached to? It's a 1'. It's only attached to 1 other carbon. This carbon is attached to 2 others, so it's 2'. This carbon is attached to 3 other carbons, so it's 3'. So let's go ahead and work on some other problems. Some more space. That's what I need, is more space to draw on the board. So let's work on this one. I'm going to give you guys a moment to try this one out. So go ahead and pause your video, try this out, and see what you come up with, and then we'll begin again. So welcome back. Hopefully you guys worked it out and tried out the problem. Your answer would be, but how do we get this answer? So that is your answer. So to get this is going to be, so let's break it down. So our bromo is attached to this carbon right here, and this carbon is a 1, 2, 3. It's a 3'. 3'. I think we're going to go Sn1 again. So how is this one formed? So let's see, that is our answer. Let us see how we get there. So we're going to make the leaving group, has to leave right here. So it's going to kick it off forming what? It forms a carbocation. So we're going to form our carbocation right here. Oh. So our carbocation is formed because we kicked off this bromo. Bromo is now over here, it's just flying away, the negative charge. And then our H2O, our solvent, oops. So our oxygen, these electrons right here, are going to attack the carbocation. So the electrons attack the carbocation and it attaches. So we're going to have a molecule that then looks like this. So, and this would be, it would have the positive charge as well. And you know that oxygen does not like, it has 1, 2, 3, 4, 5, has 5 electrons. It needs 6 to be happy. So therefore we're going to have to get rid of one of these hydrogens. So how to do that? This bromo does not necessarily go away. This is our second step. This is our intermediate in this one. It's our rate determining step. We're going to have these electrons attack one of these hydrogens. Hydrogen's going to kick off, or the oxygen will kick off one of the hydrogens. And we will form our final product, which is so our oxygen is happy with 6 electrons, and we have formed our product. This was an Sn1, and we knew this because there's a weak base. A weak base, it's a 3 prime, which we counted 1, 2, 3. 3 prime as a weak base, and therefore we realized that there's an Sn1 mechanism. Sn1, 2 things happen. We have an intermediate step, and a carbocation is formed. So don't forget that Sn1 has a carbocation that's formed, happens in 2 steps. Sn2, everything happens at once. And remember, what is a weak base? You look for first of all, you look for your substituents. And what is it? And what is it? Is it a methyl group? Is it a 1 prime? Is it a 2 prime? Is it a 3 prime carbon? Then you look, is it a strong base? Is our solvent a strong base? Is our solvent a weak base? Or is there no nucleophile? So we're going to get into this section in one of our next videos where we discuss E1 and E2. But for right now, I just really wanted to talk about Sn1, Sn2, and get you guys familiar with these. And so yeah, we'll do one more, just so you guys could get an extra practice problem in. And we'll get, this will be, let's do bromo is always a good, you'll see bromo a lot because it's just a good leading group. And we'll do water again. Sorry. Okay, we'll do water again. So, go ahead and pause the video, try this problem out, and then we'll get working on it. Okay, welcome back. So, hopefully you guys do this stuff. So what kind of carbon is this? So we know that it's a 1 prime carbon because there's only 1 carbon attached to it. So we look here. Immediately, this is the only section you're looking at. So we know that's 1 prime. Let's go ahead and circle this. Alright, so we know it's 1 prime. Now what kind of base is water? Okay, so it's a weak base. So we know that we're going to go through an Sn2. But we also know that with a 1 prime, that only Sn2 can occur unless there's no nucleophile. But there is a nucleophile. So we're going to see what will happen. So Sn1, we know that there's no carbocation formed, that everything happens at once. So that makes a very smooth mechanism. We're going to kick off this leading group, and this electrons will attach right here. So it's a 2-step, or not 2-step, but it's a 1-step process. Everything happens at once. That is the entire mechanism. And we will have an OH group right here. The water molecule will do the exact same. It'll kick off this hydrogen group to make that oxygen happy, and then the hydrogen will be attacked by the bromo, forming this. So the hydrogen plus bromo will be a side product, but this will be our major product. And not just major product, that'll be our only real product, and hydrogen bromo will be the side or additional product. So guys, thank you guys for watching. It is kind of a tough subject because you have to get used to seeing strong bases, weak bases, and no nucleophiles, and identifying which one's which. This we should already know. You should be able to identify a 1', 2', or 3' carbon and be able to do that easily. I discussed it pretty thoroughly this video, and I hope you guys could watch the video over to identify and be able to know. So this carbon would be what? Or this carbon will be which? So this carbon is attached to 2 carbons, so it would be a 2' carbon. I mean, I just want to get you guys familiar with it, but you need to be able to identify which carbon's which. This carbon would obviously only be a 1' carbon, which is why we did only 1'. But anyway, this is the table that you guys need to follow and look at for advice. Please subscribe and like the video, and thank you guys for watching. My name's Adam Beaker, Adam the Science Tutor.